Hello, everyone, and welcome back. My name's Josh Hopkins, and today I'll be showing you my design, demonstration, and verification for my ECE 5000 Electrical Engineering Design class project at Memorial University. So for this project, I chose to make a exercise bike speedometer and odometer with a working data logger and Bluetooth connection module. So to start, I will explain to you guys how my system works and how we collect data. And then after that, I'll show you guys the project and go through the design specs for it. And then that'll be followed up by an explanation of my code, and I'll show it to you guys as well. And then after that, we'll do a little demonstration showing the working system with a working data logger and a working Bluetooth connection module. So let's get into it. So to give you guys a little run through on how my system works, I'll just explain how we calculate all our data. So the way we calculate our data is we use a Hall sensor, which is a magnet sensor, to pick up a magnet that is attached to the wheel of the exercise bike. So every time the wheel is picked up by the Hall sensor, it is logged as one rotation. So the way we calculate speed is we divide the distance by the time between two high inputs. So we know the distance of our wheel is, I think, 1.14 meters or somewhere around there. And then we divide that between the time it took to do a full rotation. The way we calculate distance is we multiply the amount of rotations logged by the length of that wheel to give us the full distance we have traveled. And then the way we calculate calories is that it's proportional to the distance. So the formula for calories that I use is the body weight of the rider. So I just chose a fixed amount of, I think, 170, which is the average body weight, or 180. And then multiply that by the distance traveled, and then divide that by 2, and that'll give you your calories. Some other features that are in the system include a button, 2 buttons. The first button is used to switch between kilometers and miles. And then the second button is used to power the system on and off, as well as reset the data. Our last feature, not our last feature, one of our other features is a buzzer. This buzzer is programmed to sound off for half a second every time the rider passes either 2 kilometers or 2 miles. So after every multiple of 2, the rider will get a little buzz sound just to let them know that they've traveled so far. Some other things our system includes is an SD card data logger so that the rider can view their data after the ride. And then we also have a Bluetooth module that will stream to an app so our rider can view their data using their phone while riding. So this is our finished product. This box here is what houses all the necessary components for our system to operate. That excludes the magnet, as that attaches to the front wheel of the exercise bike. So to go through a few things here, this is our LCD screen. This will display our speed, distance, and calories burned variables to display to the rider so they can view as they ride. Down to the left here, we have our power/reset button. This will turn the screen on and off, and then also reset our data when turned back on. Down to the right here, we have our unit swap button. This will swap the speed and distance between miles and kilometers, depending on how they want it. Up here to the right, we have our SD card adapter. This is where the rider can put their SD card if they want to log their data so they can look back on it in the future. Down to the left here is where we have our Hall sensor. This Hall sensor is what is used to detect the magnet, so we're able to accurately calculate our speed, distance, and calories burned variables. Some other things that are housed in this box include the power source, the buzzer, the Bluetooth module, and then also our Arduino Uno and proto board. So the voltage configuration of this system is 3.3 or 5 volts. The power consumption is 2.1 watts. The typical current is 40 milliamps. The sensor length, so how far this sensor can detect the magnet, is about 15 millimeters. The operating temperature of this system is room temperature, so about 21 degrees Celsius. The dimensions of this box are 145 millimeters by 60 millimeters by 60 millimeters. And the weight is 0.34 kilograms, or also 343 grams. Now we will go through the code that is used in my project. So to begin, we start with all the included libraries, as you can see here. Then we move into our timer setup. We use a timer to help calculate our speed for our bike. Then we move into our Hall sensor setup. And then we initialize all our data variables such as speed, distance, and calories and whatnot. Then our LCD screen. And then we move into our SD card setup. And then all our button and buzzer setup. After this, we move into our functions. So our first function here is the speed function. This helps calculate our speed and also our distance. Then we move into our SD card setup. This helps us print data onto the SD card so that then we can view it later on a computer. After that, we have our Bluetooth setup. This helps us send data to our phone so we can look at our data that way. And then we have our unit swap function. This helps us switch between kilometers and miles. And then we have our buzzer setup. The buzzer sounds off after every 2 kilometers or 2 miles, depending on how you have it set. And then we have our restart count function. This is just used to help turn the system on and off. Then our actual restart function, this will turn the system on and off and print our data as well. And then we get into our setup. You can see here. This portion here is to help with our SD card. So if our SD card is not in our adapter, then the system cannot start. And then we get into our loop where we call back all our functions. So the restart count, the restart. So this, when the system is initially turned on, there's nothing displaying on the screen because it's turned off. And then once we click our button, our screen will light up and all the data will show. And then we have our speed calc, our unit swap, our buzzer distance. This is just to help with the buzzer. And then our buzzer sound, our Bluetooth function, and our SD card function. So all of this together helps run my code. Now I'll do my design demonstration. So since the beginning, we said we would mount the box on this little black piece here. And because it's so wide, I had to put some brackets on it, just made out of wood, just to be able to hold the system. So we'll put that here. I gotta move the magnet. And we'll get as close as we can. Now let's turn on our system. We're in miles. We want to go to kilometers. And now, oh gosh, we can start riding. From up here, just on camera, it's a little hard to see all our values. So we're getting some here now. I'm not sure if you guys can see it that well. I'll do a little zoom up. But from here, you can easily see all our variables. The rider can easily see all the variables. So now if we want to switch it to miles, we click our button. You can see our speed and distance convert. Our calories stay the same, as that is not a changeable unit of measurement. So if we continue to ride, once we reach 2 kilometers and 2 miles, the buzzer will sound off. So now I'll skip ahead to when we're close to 2 kilometers to demonstrate that to you guys. Now I've skipped ahead to close to 2 kilometers, and from here on out I'll continue to ride the next 0.02 kilometers to demonstrate to you guys the buzzer sounding off. Just trying to get a little demonstration. Go to 2, and there we go. So as we continue to ride, the same thing should happen at every interval of 2. So 4 kilometers, 6 kilometers, 8 kilometers. And if we switch it over to miles, the same thing should happen at 2 miles, 4 miles, 6 miles, and so on. I just want to put this in here before the SD card demonstration. The results from the SD card demonstration will not match results we just got from the design demonstration. This is because they were done separately. I did them separately because there's a period of time between when I was showing you guys my system working and when I was showing you guys the buzzer working that I cut out. And between that time, the speed is just absurdly high. This is because I was holding the magnet in front of the sensor just to quickly move up my distance to be able to demonstrate that for you guys. And I never thought that would be necessary to show in the SD card results, so I just did a separate run. So that's why they don't match. So without further ado, let's get into it. So if we look to the side of the laptop, we will see that our SD card is inserted. And now when we look at our data, you can see that we start off with zeros for all speed, distance, and calories. And as we go down, our distance and calories slowly increase. And then we can see that at about here, where is it? Here, we click our button to switch to miles. So now our speed is in miles per hour and our distance is in miles. Our calories stay the same. And then they continue to slowly increase. And then at the end here, you can see we have all zeros. This is because when we click our power button, our speed, distance, and calories all reset, so that then they are at 0 for the next rider. Now we'll do a demonstration of our working app. So to create our app, we used a website called MIT App Inventor. They have an app that you can download on your Samsung device that can connect with this website, so you can get the same GUI on your phone. So to begin, we got to connect our device to our app. So to do that, we can just scan our QR code, go up here, click connect, AI companion, gives us the code. You can see here. It was just loading now. Yep. So before you do this, you got to make sure that your Bluetooth device is connected to the phone in the actual phone settings. So into the settings of the phone, you have to go into Bluetooth and you'll see the device there. So once that's there, we just got to click Bluetooth, click our little thing, connect. Connect. Now you can see we're connected. So now we're just gonna get some readings. See, they're showing up over there. It's a little glitchy sometimes, but majority of the time it works. We'll get numbers up for everything now. You can see here that matches with what we have on our LCD screen. So we'll get a few more readings. Again, it's matching. A few more readings. Ooh, I held it there for too long. That's what happens when you hold the magnet in front for too long. It goes up to around 300 kilometers an hour. So a few more readings. You can see they're coming up over here. We'll get some more. There. So as you can see, our app can connect directly to our device and then also display the correct data as displayed on our LCD screen. As you can see, we have a fully functioning product that can correctly display the rider's speed, distance, and calories burned as they're riding. We also have two working buttons, one that can turn the power on and off and reset the data, as well as one that can swap between kilometers and miles. We also have a working buzzer that will sound off after every 2 kilometers or miles, as well as a functioning SD card data logger, as well as a working app with Bluetooth connection. Thank you for taking the time to watch my videos. Have a nice day.